Hi, folks. In this lesson, we're going to talk about data persistence in Java applications. And in particular, we're going to be using some conventions and a few specific set of tools within the realm of Spring Boot. And this is kind of a complicated topic in the world of Java. It also, we did it in Python in Unit 2, and it was kind of easy and it was kind of transparent. That wasn't because somehow Python is more magical. It's just because it's a little bit more kind of out of the box friendly. You don't have as much to configure or set up in order to get objects able to be stored in databases as you do within Java. That convenience comes at a price. Java's more powerful, more flexible. And so some of these configurations and tools that you're using can be used to do a lot of things that you can't do in Python. So all that to say, this is going to be more complicated than in the Python world, but that's okay. Let's just dive into it. So first I want to kind of introduce a few of the just words that we're going to talk about when we talk about these things and kind of give you a picture, a conceptual picture of how this works. So there are multiple tools that make this happen, that make it possible for us rather, to take an object, store it in the database, and then later get it back out. Recall that data in relational databases is stored in tables, right? So it looks like this. You've got, some column name, like say ID, name, email, right? And then you might have rows of data, and so on. That's what relational data looks like. It's essentially what you might call flat. It's just a bunch of fields stored in rows. The complicating factor with Java is that, for example, as we're going to see within the blogs application, objects can relate to each other. So I might have a user object, right? And that user might have like an ID, we'll call it a UID, a username, and they also might have a list of posts. So let me just specify this, right? And then you have a post object that has some fields too, right? And if you had actual objects, this might be what they look like. So you might have, say, a user named Chris and a blog post. And that post belongs to Chris so that Chris has a reference to it. Now, in the world of relational data, if this is the user table and the post table's over here, and there's some, columns and rows and so forth, those things are stored in different tables. How do they relate to each other? And when we go to get them out of the database, how do we know that one should point to the other, and how do we know to build those objects properly? That's kind of the complicated scenario that you get when you're dealing with objects and trying to store them in relational databases. So the relevant term here is a technique called ORM. This stands for Object Relational Mapping. Okay, how do we take objects, these kind of things we draw as blobs with fields and methods and stuff, and then put them into the world of relational data, which looks like columns and rows, and then have that all work back and forth transparently in a reasonable way. Okay, so ORM and describing that world is what we're into today. So the way this works in our setting, the way we're going to use it, it's going to involve a few different pieces of jargon. So let's just draw some stuff here. So I'll draw my Java application over here. This is my application. And then over here, I have a database. Okay, and it's going to be a long road to get data all the way from my application into the database. And there are different pieces in the middle. So the first is Hibernate is the big one. And you're not going to see the word Hibernate other than in a couple of places. Oof, that's rough. Let me fix this. Here we go, Hibernate. But Hibernate is actually the important piece. It's an ORM, or an Object Relational Mapping Tool. All right, so Hibernate sits between our application and the database, and it's going to translate for us from this world of objects up here to the world of relational data down here. It's going to translate back and forth and kind of do that in a pretty transparent way once we set it up properly. But we need two additional things to get this to work. Hibernate itself needs a way to talk to the database, right? It needs to be able to speak to the database. And in particular, we're going to use SQL databases, MySQL databases rather. But you might have it. There are any number of types of database engines out there. There are Postgres databases. There are Oracle databases. There are lots of different types of databases. There are non-relational databases. And so Hibernate needs to know how to talk to all these different databases, and JDBC is the mechanism by which Hibernate talks to the database. So JDBC stands for Java Database Connectivity. It's supposed to be equals. There we go. Java Database Connectivity. Really legible, right? So JDBC is going to be a component that will take queries and go talk to the database. Do that mechanical piece of figuring out where it is, making a database connection, running the query on the database, getting the results back. On the other side, my application, in order to work with Hibernate, is going to need to be configured properly. And so for that, we're going to need to use something called JPA. And JPA stands for Java Persistence Annotations. All right. So Java Persistence Annotations. And JPA is a standard. It's more or less like a specification than it is an actual implementation. And it's going to be what we use to annotate our classes so that Hibernate knows how to store them. And to do that in the right ways. And we'll see what that means when we get into the code example today. So these like three basic pieces are necessary to get us from Java to a database. We need JDBC in order to make a physical connection to a database and to run queries in whatever kind of language or standard that database uses. We need Hibernate to be able to translate between the worlds of objects and relational data in order to take objects apart, put them into relational tables, and then to take data from a relational database and put them back together in the form of objects. And then we need JPA in order to tell our application how Hibernate should do its job. All right, so those are the three pieces that we're going to look at conceptually today and see how to get them to work. This is a complicated picture. You might be scratching your head and thinking this is way too much. It turns out that once you get to using these things together, it's really a lot easier than the picture makes it seem. And while it's not necessarily simple, it's at least doable. You can learn the different tools that you need to do so. So we're going to return to our Hello Spring application. And let's just go ahead and look at what this does. We'll remind ourselves real quick. If I go to this /hello, the application renders just a little form with a say hello button, and I can say, just put a person's name in there and hit say hello, and it will print out the message, hello, Zach. You added some different functionality that I haven't actually put into mine where you let people choose the language. We're not going to worry about that right now, but that's fine. You're not going to need to take that out or anything in order to follow along with this example. Okay, so the first thing we need to do in order to get our application to talk to a database is to actually have a database. So I've got, let's see, I've got my database engines set up here. This is a MySQL database. And we did this in a separate walkthrough video, so I'm going to assume you already have this up. So the database piece is already there. Then I'm going to need to, we talked about some different things. We talked about JPA and Hibernate and JDBC as the tools that allow our Java applications to talk to the database. We need to actually pull those in using Maven. So I'm going to open up my POM. And let's see, in dependencies, these are the dependencies I have. So I need to grab some, and I'm actually just going to go copy paste. I'm going to cheat a little bit. I'll include the specific dependencies that you need in the course page for the site, but I'll go to another POM that I have that just has them. That way it'll be a little bit easier. Let's see. Definitely need these two, the JDBC and the JPA. And then I'm also going to need this MySQL connector in a second as well. All right. So I got those two. I'm going to need this MySQL connector. And that's it. So JPA will pull in Hibernate for me as well. So that's kind of an implicit dependency, transitive dependency, you might say. Okay, so now I've got all these in my project. Now I can start to use them. Maven will go ahead and suck them in for me. One more thing I need to do is I need to tell my application specifically which database it should use and how it should use it. So I need to use my application.properties file for this. Remember we saw this when we were configuring our templates. We set the one property up to disable time leaf template caching. Let's go to, again, I'm gonna cheat a little bit and go to another application that has a similar set of settings and drop them in here. And again, I'll provide a link to this for you. And we're gonna need to update a few of these things. So in particular, this little block of stuff specifies the connection settings for my database. And in particular, it has, this is the database name, this is the username that I should connect with, and this is the password I should connect with. I need to update these. I haven't created these yet, so let me go ahead and just make them whatever I want. I'm going to make this one called hello. And a convention I like to use is that every application has a database that reflects that application's name, and then the user has the same name as the database. So you basically have one database per application, one user per application, and that kind of keeps things nice and clean so your applications can't mess with each other's databases. All right, so I'll leave that password the same. If you were using this in the real world and like an actual production application, obviously you would use a better password. But now let's just go create this database. So I'm in SQL Pro. If you're not in SQL Pro, you can do the analogous steps here. I'm going to add a database called hello. Once I have that database, I'm going to come over and add a user. Okay, and I've added the user, but the user doesn't yet have permission to mess with my particular database. So I'm going to go to hello, and I click on schema privileges, and I'm going to add basically all of these privileges to the schema hello. Schema is just a pseudonym for database in the world of MySQL. So this says that my hello user gets all of these permissions on the hello database, but notice that that hello user doesn't have any permissions on any other database. Okay, I hit apply, and basically that will set up my database to be able to talk to my Java application based on these settings. Okay, so the rest of this stuff is, you can kind of read through this. This is just going to, some useful stuff that will configure our application to work properly. This says that the database we're using is a MySQL database. This is a useful one if you're having problems with your database. You can set this to true, and this will log all of the SQL queries in the console window for you when they happen. And it can also just be interesting to see how those work. Actually, let's just go ahead and set that to true for now. We'll see what that looks like as we create our application. Let's see, and all these are just kind of a little bit esoteric. We're not going to get into the details of what these are. You can just copy and paste them from the files we give you for now. All right, so now our application is completely configured to talk to our database. So here's what I want to do in order to implement some actual functionality that I can store in my database. I want to create a new model class. I'm going to create this one called hello log. Okay, and my hello log is basically going to keep track of every time I said hello. So it's going to say, it's going to have a private string name. It's going to be who I said hello to. It's going to have a private date, timestamp, when that occurred. Use Java util date. What else should it say? That's probably all we need, right? We just want to be able to say when those different things happened. Let's go ahead and create some getters and setters. I'm going to use this little helper method within Eclipse. I want to use getters and setters for all of these after timestamp. Okay. There's my getters and setters. All right. Cool. That looks pretty good. So in order to use this, every time I'm in my hello controller, someone passes information over to me, I'm just going to say that I'm going to create a new hello log. I actually don't have a constructor yet, but let me just go ahead and put it in there first. My constructor should just take one parameter. Which is the name. The date, the timestamp, we can just set by just creating a new date instance. And by default, the date constructor will give us the time, the current time when we do that. All right, so we don't need to pass the date into our constructor. Okay. One more thing while I'm on the topic of constructors that I'm going to do is I need to create what's called the no-arg constructor. All right. No-arg is just short for no argument constructor. And this is required for Hibernate. Hibernate will not work correctly if you don't have a no-arg constructor on the class that you want to store in the database. And this just has to do with the way that Hibernate works. And we'll talk a bit more about this in a second, but I just need it. Just know that every class that you want to put in Hibernate, in particular every model class that you're storing in the database, needs a no-arg constructor. Okay, so now what's going to happen is every time my controller comes in here, it's going to create this new object, and that's it so far. I still don't have any code connecting this to a database. All right, so let's go and talk about the JPA level. Let's talk about how we configure this class to be stored in a database. So I do that using a set of annotations. The first one I'm going to use is called entity. Entity is just, notice when you get these, when you organize your imports, you want to use the Java persistence, the Java X persistence, not the Hibernate annotations. The Java X persistence are just a little bit more general, and if you ever decided to use a different ORM tool other than Hibernate, you wouldn't have to change all your annotations and imports, but they'll do more or less the same thing. So we want to use entity. We also want to say that we want to give it the name of a table to store my data in. Okay, so we're going to have a table called hello log that will store all these hello log objects. All right, so that tells it which table to store information in. I then need to tell Hibernate which fields get stored in that table and how. And so you can do this in different ways. You can put annotations up here to configure it, where you define those fields. I tend to do it on the getters, which is another way you can do it. So here, I can say that I want by configuring the get name getter, this will allow the name property to be stored. The only annotation I actually need in this situation is the column annotation. By saying column and then name equals, that will tell the application to put the name property in the name column within the hello log table. Okay. Then let's go to timestamp down here. So I'm going to add, say, column. And this one gets another annotation not null. Okay, so this will basically say both to Java and the database engine that this property should not be null. Don't allow me to put this in the database if it's null. Okay, there's another way you can do this. You can say nullable equals false. That will configure this at the database level. It won't let you insert a row with a null timestamp. But by doing it using this annotation, you get both the enforcement at the database level as well as the level of Hibernate. Hibernate won't even let you get to the database if your timestamp is null. Okay, cool. So now our object is configured. We added 2 annotations on the class to set it up, and then we added some annotations on the properties themselves. The situation where you have more complex relationships between objects, where say you might have an array of other objects stored by the hello log, that is going to be, we'll come across that in the blog's problem set, your final problem set, and we'll show you how to do that and provide some references, but that's going to be a little bit more complicated. You'll have to add some additional annotations to get that set up correctly. Okay, so that's it. So the last thing we need to do is we need to give our application a way to actually do the mechanical piece of saving and retrieving data from the database. All right, how do we ask the database for an instance of a hello log object? And to do this, I'm going to create a new package, and it's going to be within my models package. It's going to be called DAO. DAO is going to stand for Data Access Object, and then I'm going to go within there, and I'm going to create a new interface called Hello Log DAO. This is going to be the data access object that lets me easily query the database for hello log objects and to easily save them. So in particular, there's a little bit of magic that's going to happen here with dependency injection. So let me just make sure. Let me look at a previous instance. I can't remember if I need to add an interface or where am I? Yeah, so I want a CRUD repository. There we go. So what we're going to do here is we're going to add a CRUD repository. And we actually need to do one more step here. I'm going to put an integer. We need to actually go to a little bit more work to provide identifiers, in other words, primary keys for our objects, which I forgot to do before. So I'm going to go back to hello log, and I'm going to say private int UID, and then I'm going to add getters and setters. And on the getter, I'm going to configure this with some special annotations. All right, and I'm going to say column name equals UID, unique equals true. My UIDs should be unique. And then I'm also going to make this not null. Okay, so let's recap that. I did that pretty quickly. So this is just going to provide a primary key, in other words, a unique identifier for each instance of a hello log object. Every object I create will have a unique identifier. In particular, ID says to hibernate in the database, this should be what's called a primary key. In other words, it should be a column, and it should correspond to a column in the database that is unique and uniquely identifies that row. Generated value means that Hibernate will create a value for us. It'll use some algorithm to generate a unique integer for every one of our objects. We've seen not null before, and we've seen column before. Unique here just says that each of these UIDs should be unique. Okay? So I needed to add this in particular for my data access object. Notice I have integer here. This is what's called the generic or a parameterized class. A CRUD repository is a special kind of class that will let us look up hello log objects that have integer primary keys or integer identifiers. Okay, so this little piece here, I got to there and realized that I forgot to create my identifier field over here, and so I just did that here. Okay, good, good. Now within this class, this is an interface, right? So here in an interface, recall that you just define your method signatures. You don't actually provide implementations for them. So all I have to do here in this DAO interface is specify the methods that I want to be able to use without actually implementing them. So in particular, I want to be able to do something called public, create a public method that returns a list of hello logs. And I'm going to call it find all. Okay? And this name is very carefully, very specifically constructed, and I'll talk about it more in a second. Let me create another list, or not a list, but a public method that returns a single hello log object. Okay, and it's going to be called find by UID. So the magic about this scenario is that I never have to write a class that implements this interface. What happens is when my application runs, Spring will actually do this for me, and I need to add a couple of annotations for that to actually work. I need to add repository. There we go, and I believe that's it. Let's check this. Oh, transactional. Yeah, so let's do transactional as well. Transactional is not required, but it's a good one to have. All right. So when I go to run my application, Spring will create a class that implements this interface for me, and in particular, it will implement these two methods for me. So I don't necessarily have to know the mechanics of how to ask Hibernate for all of the hello log objects in the database. I just have to write a method in my interface called findAll. And this is very particular. FindAll is a method name that Hibernate and Spring recognize. Okay, I couldn't say find all my objects. All right, that would not work. Spring would not be cool with that. So if I say find all, it's going to be able to generate that method implementation for me. Similarly with find by UID, this method will take an integer identifier, which we saw was going to be our primary key column. It's going to be the unique integer assigned to every single object. And it will look up that particular object out of the database and return it. If I, did something like this and said find by unique identifier, that would not be properly constructed for Hibernate and Spring to properly build the implementation of that method for me. So I have to use this naming convention. In particular, we use what's called camel casing here. So camel casing means that the first letter is lowercase, and then you have this the first letter of each word in the method name after that are uppercase. And so I can do find by, and I can do find by anything. I can say public list hello log find by name. Recall that name is a property on our hello log object, right? So hello Zach, hello Jesse, etc. It's the person that we said hello to. So I could find a list of all of the people and all the instances in which I said hello to that one person, okay? And again, I use this convention, find by, and then the name of that property capitalized. Then I have to use the exact same spelling. I couldn't if I did, if I did a lowercase n, or if I did an uppercase n and something crazy like an uppercase e, that wouldn't work. I have to use this explicit conventions. These property names need to correspond to the uncamel-cased, the normal version of the property names in the class. Okay, so I'm not going to need this one. I just did that for demonstration. Let me take it out. Great. One last piece before I can actually use this repository. I need to create one in my controller, right? I need a private hello log DAO. This is just going to be an instance property for my controller class. And I want to be able to do something like down below, when I create this log item, I want to be able to say something like log.save, sorry, not log.save, hello log DAO.save log. That will save that object to the database. Okay? Right, so there's only one problem here. This is an interface, and I haven't implemented that interface. So how do I actually get an instance of an object that does implement that interface? Well, it turns out I can get around that by letting Spring do the work for me. I can use Dependency Injection to auto-wire or to inject an instance of this interface. And Spring will create a class that implements the interface and inject it into this class for me. Okay? For this to work, I have to be within a controller, and I have to set that instance property to be auto-wired, and then it will just be accessible to me whenever I go to use it down here. Okay, so let's just go ahead and test this out. I'm going to have to restart my application. We'll test this out, and then we'll actually display each of our log messages in the page as well. Okay, so let me go ahead and restart, and let's look at the console, make sure nothing blows up. Frequently you'll get console errors when you're messing with database stuff and getting it set up for the first time. So I'm crossing my fingers right now. And it worked. That doesn't happen that often. We only made some simple changes though. So, but notice I have a lot more log messages here. Notice I have some Hibernate related messages here. Yeah, so our log is growing as we're adding functionality. Our startup log is growing as we're adding functionality to our application. Let me go show you one more thing too. Let's go actually look at this database. I'm in the hello database, and I'm just going to hit refresh. Notice that I have a table here, and that table has 3 columns. I didn't make this. Recall, I didn't make this table. All I did was over in the hello log object, or hello log class, I specified the name of the table. And then I specified which properties, UID, name, timestamp, should be stored in that table. When I started up the application, Hibernate looked at the database, it found that table wasn't there, and it built it for me. So this in general is going to be the case when you're using Hibernate and Spring Boot. And it's not always the case. If you weren't using Spring Boot, you would have to manually build the tables yourself. But in this case, Spring Boot will actually look and see that those tables do not exist, and it will create them for me. That's pretty handy. Additionally, if I go in here and added another field to my hello log object, the next time I restart my application, Spring Boot would notice that field wasn't in the table, and it would create that new column for me. Okay, so that's pretty handy. It takes a lot of the extra work out of our hands. Okay, so let's go ahead and use our application and see if we get data. All right, so our application worked. Let's go check out our table, see if there's any data in there. And there it is. We have a unique identifier that was generated for us by Hibernate. We have the name field, and we have the timestamp. Let's see, it's September 7th at 1:57. That looks pretty much correct. So that got inserted into the database. So there we were able actually to write data to the database. We haven't actually read any data out of our database yet though. So let's go ahead and add that last step. So if I just, if I continue to use my application here, just as a quick demo, I would continue to get data piling up in the database. Pretty cool, huh? Let's go ahead and see how we can get data out of the database. Let's create a new view and a new controller. I'm going to go to templates. I'm going to say that, let me copy this hello template. I'm going to use most of the stuff in here. And I'm going to create a template called log. So instead of just displaying the name, here I'm going to do something else. I'm going to create a list. And within that list, I want to display the log of all hellos. Every time our application has said hello to somebody. And in particular, it should look something like this. I should say li. We said hello to somebody at some time. That's what we want our messages to look like. Okay, so we'll come back and get this template into shape, but first let's get the data out of the database to properly render this template. So let's go to, I'm going to need to make a new controller method. So let's say public string log, and I'm going to need to get the model. I need to use the model to pass data into my template. I don't think I'll need the request. We can always add it though if we just discover we need it later. My controller method is going to use the log template, so I can just return log. And I have a couple to-dos here. I need to get data out of database, put data into template. Okay. Let me set up the route here first, though. Is it value or name? Value. Yeah. Okay. And I'm going to leave off the request type because this should just work for get or post the same way. All right, so here I need to get the data out of the database. I want to get every single instance of a hello log object that has been inserted into the database. To do this, well, first I want a list of hello logs. Okay, to do this, I can use my data access object. All right, and recall that it has some methods for me. In particular, it has find all, that method that we put into our interface. So this method right here that we put into our interface, that's accessible for us, and it will return all of the objects since we've been properly configured. All right, then we need to pass that data into the template. So I'll say model.add attribute. And there we go. I think that's it. I think that's pretty good. Let's go then iterate over this stuff in our template. All right, so we're in our template, and we want to basically, we've passed this entire list of log objects. All these logs, we passed it into our template. We then need to display all of them. We need to basically create a loop within our template. This is something you might not have done before, so I want to make sure we demonstrated it. To do this, you use the time leaf tag th:\each. Okay, and this will give us the ability to loop over all of the objects in a particular list. So our list was called logs, right? Yep, there it is. It's called logs. So I want to say for each log in logs. All right, and so by putting this each tag, this time leaf each tag within the li, this says repeat this line, this entire li elements for every single item in the list. Okay, in particular, if I have 3 items in the list, I will get 3 li tags with whatever happens to be spit out in the middle. All right, and this is where we get to use some of that functionality. So here I'm going to create span tags just for the purposes of actually holding these things. So I want to say th text equals, and here's where I want the person's name, right? So we know that our log object has a name. I can say log.name. I can just use the syntax. Notice that this is a loop. This is kind of like a for each loop, or the for in loops in Java. And for every property on the object that has a public getter, I can say just .name, and that will use timeleaf will use that property's getter to retrieve that property. Okay, and it will then insert that name into that tag. So let me create another span to hold the date. And here, let me see, I need to get a piece of information on my clipboard. This is just so I don't have to look up the syntax while I'm doing the video. I already looked it up a minute ago. This is for formatting a date. And we're going to format our date as follows. Okay, so I'm still going to use the th:\text attribute. And then within my $curly brace, I'm going to use this special formatting function. Okay. And here, instead of post.created, I want to say log.timestamp. So this will pull the timestamp property off of my log object, and it'll format it according to this formatting string. And that's just something. There's a list of, you can search Java util date formatting strings, and that will show you how you can use different combinations of characters there to set the format. This will just format our date object in certain ways. Okay, so that should do it. This entire line will repeat once for every single log in the list of logs. If you you don't have to use one line. If you had multiple lines, all that matters is that the li element repeats once, because that's the one that's attached to the th:\each. So something to pay attention to there. All right, go ahead and restart my application, and then we'll see if this worked. All right, we've restarted. Okay, so I should be able to go to this new URL. And there we go. So we have a list now of all the log objects within our database. And if I go to then say make a new one, and then I go check the log, notice I get that new one down at the bottom. All right, and might have been more useful to include the time in there, but we have the date at least. So you can, if you're interested in that, you can look up how to properly format that date object so that it actually includes the time. There you go. So one more thing. I said before when we set up our application.properties file that we turned on this property equal to true. Let me show you what that did. If I go to my console now, if I look down at the bottom here, I see that I actually have some SQL-like queries. This is kind of cool. This shows you the queries that Hibernate will run through JDBC against the database. So this is kind of making a little bit more transparent all of the work that Hibernate's doing for you. It's running this select query to pull different log objects out of the database. This was the first time we loaded the log page, right? And so it loaded all of the log objects. Kind of has its own little way of generating these queries, which is why these little guys look weird. We have an insert. That's when I went and ran the hello form again to create a new one. And then we have another select, which is when I went back and looked at the log page again. So these queries are all happening for you in the background. And more than those queries, when, for example, this insert came back, or this select came back, this was just a bunch of rows in a relational database. And Hibernate then took those rows and created objects. It created new hello log objects using the data from those rows as the properties. And this is where the no Arg constructor comes in. Hibernate, notice that I don't have a constructor here that uses the three properties that are stored in the database. And furthermore, Hibernate can't be so flexible as to always know whatever constructor you might use. So what it does is it uses this no Arg constructor to first, for each row in the database, it's going to create an empty object, and then it's going to call all of your setters to then set all of those fields in that object, right? So it's kind of a cool, clever way to do it, and that's why you need these no Arg constructors, because this is the way that Hibernate brings those objects back to life, is by creating an empty object and then wiring up each single property as it goes. All right, so again, I'll make the source code available to you along with some notes and links to relevant documentation. But those are all of the same piece, all the relevant pieces that you need in order to use persistence within your Spring Boot MVC application.